Okay, so this is problem number 7 from exam number 2. And a lot of us struggled with how to answer this question. So I want to make sure to give you some answers, at least the ones that I think are acceptable, the way I would do these. These are not the only way to answer them, but this would definitely get you possibly full credit. Yeah. So we'll start with 7a. This might be more than one video, by the way. It might take 2, possibly 3. Why is the domain all real numbers except -3 to 3? The best answer I've seen so far is the following. Note that f is defined for all real values, but not x equals 3 or x equals -3 because plugging in these two values results with a 0 in the denominator. That's really all you needed to say. There's lots of ways to say this. Some of you use more sentences, but this was enough. Notice that if you plug in, so now this is me just explaining, that's not part of the answer, but notice if you plug in -3 or f, sorry, 3, so f of 3, you would get 2 times 3 squared minus 9 over 3 squared minus 9, which would give you 18 minus 9 over 9 minus 9, which is 9 over 0. And that's the problem, okay? And we're not taking limits, we're actually plugging it in. And it turns out if you plug in -3, you also get 9 over 0, okay? So that, again, that's the big issue here. So that's the only thing I tell you to be careful with. So that would have been a good answer for 7a. That was all that was needed. All right, 7b. Now this one might need some scratch work, and that's where I would start first. So the scratch work would be as follows. So I would first, maybe make some scratch work, and then I would look at the problem. So f of x is 2x squared minus 9, x squared minus 9, and which equals 2x squared minus 9 over x minus 3, x plus 3. Okay, so what we're going to do is we're going to make a table of values, and we're going to put 3 right in the middle. And we already know when we plug in 3, we get 3 over, we get 9 over 0, which is bad. All right, we already know that from our calculations in part A. The top number is the x, the bottom number is the f of x. And then what we're going to do is we're going to pick values really close to 3. So for example, 2.9 is really close to 3, and 3.1 is really close to 3. And as I do these, I'm going to notice a few things. First of all, when I plug this into f, right? 2 times 2.9 squared. 2.9 squared, that's pretty close to 3, so that'll be almost 18. So it's almost 18 minus 9 over. And then I notice that when I plug in 2.9 in here, I get a negative answer. And then when I plug in 2.9 here, I get a positive answer. And so notice that this gives me a negative answer. Whereas 3.1 again is really close to 3. When you square it, it's approximately 9. 9 times 2 is 18, so I get 18 minus 9. And then when I plug in the 3.1 here, that'll actually be positive. And when I plug it into the second one, to the x plus 3, that's also positive, so this is positive. Now, let me pick a smaller numbers closer to 3, so 2.99 and 3.01. Again, when you square the 2.99, this is really close to 3, so that's like 9. 2 times 9 is 18, so this is almost 18 minus 9. But here, when I plug in 2.99 into that one, that's negative, and then the next one is positive. So I still get a negative answer. And then same thing happens on here, is that when you plug them in, it's approximately 18 over minus 9 on the numerator, but in the denominator, you get positive and positive, so this is positive. Worst is that these numbers here, especially the part that I'm going to highlight in green, this part's getting really close to 0, because when you plug in 3 into there, this is really close to 0. So it's almost like this is equal what we had earlier, right? Which is 9 over 0. But notice that on the left-hand side, these are negative, and on the right-hand side, these are positive. So what that means is on the left-hand side, you're going to negative infinity, and on the right-hand side, you're going to positive infinity. So that's sort of how I go about this. I use the answer for part A, but then this is the scratch for part B. And then I just write, okay, so part B, note that the limit as x goes to 3 from the left, that's this one, of f of x is equal to negative infinity, and the limit as x goes to 3 from the right of f of x is positive infinity. Thus, x equals 3 is a vertical asymptote. Of f. Okay, and you can make a similar table. So again, maybe I'm going to keep this over here so I can continue my scratch work. You can make a similar table here on the right. Yeah, sorry, just making sure I got the right problem. You can make a similar table here on the right, and you're going to plug in, we already know that if we plug in -3, again, we get 9 over 0. And then, but here we have to sort of think backwards. Here, -2.99 is really close to -3 and -2.9, but it's opposite because we're on the negative side. So -3.01 and -3.1. This is why I always start with the positives first, to make sure I understand the positive version. And then again, I'm still using the same expression. I'm still using f of x is equal to 2x squared minus 9 over x minus 3, x plus 3. The numerator is still approximately 9 for all of these, because if you these numbers are so close to 3 that when you square them, they're very close to 9, and 2 times something close to 9 is close to 18, and 18 minus something close to 18 minus 9 is still 9. So the numerators are always about 9. And then this denominator here is the one that matters. So let's actually focus on the one on the right first, on the left first. So when I plug in -3.1 into this one, I get a negative. When I plug in -3.01 into the same one, I get a negative. And notice that these will be -2 and these will be -2. The one that matters is the one that's being highlighted in green. Things will change. So when I plug in -3.1 into that, I'm actually going to get a negative answer. And when I plug in -3.01, I'm going to get a negative answer again. But when I plug in either -2.9 or -2.99, I'm actually going to get positive and positive. So again, this side seems to be, on the left-hand side, we seem to have positive infinity. And on the right side, we seem to have negative infinity. And so now we can say, similarly, since the limit as x goes to -3 from the left of f of x is infinity, and the limit as x goes to -3 from the right of f of x is negative infinity, sorry, then x equals -3 is a vertical asymptote, or maybe is also a vertical asymptote of that. And there's that one, and that's all you had to do. So that's part A and part B. The next video will focus on part C and possibly, yeah, probably part C and part D. So hopefully this helps. Oh, I didn't. Oh, the symmetry. Oh no, I think we'll leave it like this. All right, thanks.